Welcome back, everybody, to video number 3. So our goal for today, given a story about an exponential situation, you will be able to use the compound interest formula to write an equation and solve. All right, so we are going to be working with word problems today. You are definitely going to be needing your graphing calculator, okay, a writing utensil, and your note sheet. So let's go ahead and take a look. And we're going to start by just looking at the compound interest formula. All right, and this is what it is. A equals P, parentheses, 1 plus or minus R, all raised to the n power. Okay, and here's the breakdown of what that is. And this is a formula that unfortunately we are going to have to memorize. However, we are going to use it enough that it's going to become just second nature to you. All right, so we do have to memorize that formula. All right, so in this formula, A is the amount that you have at the end. Amount at the end. All right, P stands for the word principal. Okay, what I like to think of it, instead of the word principal, I like to think of it as this is your starting amount. Okay, R is going to be your rate. Okay, so it is going to be your rate as a decimal. So typically rates, like it's going to increase at 2% or 20% or 15%. It's given to you as a percentage. So what we have to do, so let's say we had 2.5%. What we're going to have to do is move this decimal over 2 spots, 1, 2. So what we're going to use, our R here is going to be 0.025. So we have to bring the decimal over 2 spots. Okay, and then N is going to be the number of times something will occur. Number of times it will occur. And that is compound interest formula. So that's the breakdown. So let's talk a little bit about what compound interest is. Well, compound interest is something that happens, for instance, in a bank account. So you put money in the bank, and every time, every month, it's going to give you an interest rate. So it's going to increase. But then the next month, it's going to be the new amount, and you're going to continue increasing. So that would be compound interest when you're adding. It's getting bigger. Now, another example of compound interest when it's decreasing would be, for instance, the value of a car. So you go to the store and you buy a car, and then every year after you own that car, it's not worth the same amount it was when you first owned it. Every year it goes down in value. So that's compounded interest when it's decreasing. All right, so let's go ahead now and let's look at some exponential stories and plug them into this formula to solve. So number 1, the Amherst Booster Club raised $40,000 for a sports fund. Each year, the fund will increase at a rate of 6% due to fundraising efforts. Determine the amount of money to the nearest cent that will be in the fund after 3 years. Okay, so let's go back to our problem. So we need to figure out what all of our values are. So first ask yourself, what are we trying to solve? We're trying to find the amount of money to the nearest cent that will be in the fund after 3 years. So we're trying to find the A value, the amount at the end. So let's see if we can find everything else here. So our P value, our R, and our N, those are the 3 things we need to solve for. So the Amherst Booster Club raised $40,000 for the sports fund. So we're starting with $40,000. It's going to increase at a rate of 6%. So if it's 6%, we have to change that to a decimal, so we have to move it over 2 spots. So it's 0.06. All right. It's going to rate 6% each year. So it's going to happen each year. And how many years are we going to have the bank account for? 3 years. So that means it's going to happen 3 times. So let's go ahead now and let's plug everything in. So A equals P plus 1 plus or minus your R, all raised to your N. So then this becomes A is equal to 40,000. Now we have a 1. Now we have to decide, in our bank account, is interest going to raise up or is it going to decrease? Well, it's going to raise the amount, so we're going to use a plus. 0.06 all raised to the n. So then A is equal to 40,000. And then we're going to add those together, so 1.06. And at this time, I'm going to, instead of putting an n, I'm going to put the number of times, which is 3 times. And now I can use my handy-dandy calculator to go ahead and do this for me. So I'm going to go ahead and clear everything out. So 40,000, parentheses 1.06, and we're going to raise it to the 3rd power. And the amount at the end we're going to have is $47,640.64. So by putting my money into a bank account, I was able to make a little extra cash. All right, let's take a look at another example. Miss Keppel bought a car for $12,250. Each year, the car loses value at a rate of 7.5%. How much will the car be worth after 5 years? So once again, this is compound interest, but this time, instead of gaining value, we're going to be losing value. So let's go ahead and figure out what our P, our R, and our N values are. So my principal amount, the amount that we're starting with, is $12,250. Every year, the car loses value at a rate of 7.5%. Now that's a percent, and now I have to move it over twice, so this becomes a rate of 0.075. And then it happens every year, and we're going for 5 years, so my N is going to be 5. So let's go ahead and plug it into our formula. So your amount at the end is equal to $12,250. This time we're losing value, so it's minus 0.075, all raised to the 5th power. So now I'm going to go ahead and subtract that. 1 minus 0.075. So here we go. Okay, so now I'm going to go ahead and just plug it into the calculator. There we go. So after 5 years, the car is only going to be worth $8,295.54. Now we've got our value of the car. All right, one important thing that I would like to clarify. If we take a look in the first one, this was increasing, and in the second one, we were decreasing. Look at your rate on the inside. When you're increasing, the rate is bigger than 1. When you look at your decreasing, now our rate is going to be less than 1. And that's an important observation to make here. So let's go ahead now and take a look at number 3. All right, number 3. Mr. Kenzie invested $2,000 into a bank account that increases in value at 5.25% twice a year. How much will Mr. Kenzie have after 2 years? All right, well, let's go ahead. So here we have our principal. Mr. Kenzie is starting with $2,000. Okay, it's increasing at a value of 5.25%. Now we have to move the decimal over to get our rate, so that goes over 1, 2, so this becomes 0.0525. And the number of times. So here it says that it's going to go twice a year for 2 years. So how many times is that going to happen? It's twice a year for 2 years. So 2 times 2, it's going to happen 4 times. So now we're just going to plug all of this into our formula. It's going to be 1, and this time we're going to add because it's in a bank account, so we're increasing our value. And it's happening 4 times. So now I'm going to go ahead and add together what's in the parentheses. Now if I look very carefully, this number here is bigger than 1, and because I am increasing, this value should be bigger than 1. Let's go ahead now, plug it in the calculator, and see what we get. Oops, I gotta put a 5 there. All right, Mr. Kenzie after 2 years is now going to have $2,454.25 in his bank account. Let's take a look now at number 4. Maddie is saving to buy a car. She initially has $1,500 that she puts into a savings account at a bank. The savings account will increase at a rate of 5.1% every month. How much will she have after she saved for 2 years? So the amount she's starting with is $1,500. The rate is 5.1, but remember we have to move that over twice. So this, that's a percent. So this becomes 0.051. Now, how many times will it happen? Well, here it says it's going to happen every month for 2 years. So how many times is that every month? Well, there's 12 months in a year, and it's going to happen for 2 years. So 2 times 12, it's going to happen 24 times. Okay, so now let's plug it into our formula. A equals our principal. 1, we are increasing, so it's 1 plus 0.051, all raised to the 24. I'm going to go ahead and combine what's in my parentheses. This value is bigger than 1. That means we are going to be increasing. And now I can let the calculator do the work for me. And she will have saved $4,949.44. All right, let's go ahead. We're going to flip over one. All right, so let's take a look at this one where we're going to combine our compound interest with our graphing. So Kelly babysat all summer and was able to make $400. She invested her money into a savings account that she will earn 5.6% every month. Write an equation f of n to represent how much money Kelly has earned after n months. Okay, now if I look at this, this is very similar to what we did in the front. We're starting with an amount, and it's going to increase, okay, by a percentage. So I can use my compound interest. But instead of saying A equals, they want us here to say f of n equals. So f of n equals, and now we're going to fill it in. The amount that we're starting with is 400. And then here is our interest rate, but remember 5.6%. We have to move it over twice. So this becomes 0.056. 1 plus 0.056, all raised to the n. So if we wanted to, we could simplify what's in the parentheses. 1.056 raised to the n. And now we have written our function. Now part B says draw the graph to represent the amount Kelly has in the bank. Use a domain from 0 to 10. So remember, this is what we call a restricted domain. So they're telling you exactly what they want you to put in your x values. In this case, x is actually our n, and y is our f of n. So let's go ahead, use our calculators, and let's find those values. So we're going to go to y equals, and we're going to type in our formula. Now instead of n, our calculator is going to type in x. Okay, now we need to fill in our chart. So we're going to go to our table of values. And this time, they told us to go from 0 to 10. So they're telling us automatically, these are the only points that they want us to graph. Okay, so I'm going to go ahead and use my calculator to write that in. So at time 0, Kelly has $400. After 1 month, she now has $422.40. I'm going to have you pause the video now and write in the rest of the. Okay, now that we have our values, we have to go ahead and mark our axes so we can graph. So this is going to be our month, and this is going to be our money, our y-axis. All right, so I can see on my y-axis, I'm going to have to put a break in my chart because I'm not going to be able to start at 1. And I have to go from 400 all the way to 689. So I'm going to go ahead and count by 20s. So go ahead, pause your video, and write that up your axes. All right, I also counted by 1s on my x. And now I'm going to have you go ahead, pause the video one more time, and plot all of your points. So as you can see, we do have a nice little gradual curve here. All right, you're going to go ahead and try the next page on